Site 112, I'm Anshul Kadan and this is my video explanation for task P2. So in this task we would be analyzing the avocado data from year 2015 to 2018 in the USA region. So this is my first task requirement, and here I have imported the Panda library using the alias method as a PD. So if I execute this particular shift enter, this is the first task. Read the CSV file into a data frame. For that, I've used the pandas inbuilt read CSV function to do so. And here I've stored that particular data in the data variable using pd.read CSV. And all good. So here's my data. So this data is pretty huge. It has 18,249 lines and 14 columns. So display type, memory consumption, and non-null count information using the info method. So with pandas data frame, we have this info method which will give us this following information, as you can see on the screen, like the index, the column, non-null count, and the data type. You can see this right here is unnamed. They're starting from 0 all the to 18248, and we have date, average price, total volume, 4046, 425, 4770, and for this, what these are here, these are price lookup codes, 4046, 425, and 470, and we have non-null values in all of them, so data is pretty clean, and there's no missing values that we need to deal with. And here are the data types of that. Unnamed is int 64. This type is object. Reason is object as well. So we have 9 data types of float, 9 entities of float data type, 2 entities of int64, and 3 entities of object. This right here is the memory usage. All of this is done using the info method. And after that, so what the task requirement was to display the unique values in each column. For that, I've used the nUnique functions, and here is the result of it. Number of unique values in each column. So unnamed 0 has 53 unique values, and date has 169, average price this much, total volume this much unique values. Alrighty. So fourth task requirement was to display all the let me execute them. Yep. Shift enter. Number 3. Shift enter. Shift enter. Number 4. Yep. Display all the rows of the data Jupyter Lab displays by default. So for that, we just write the data frame, that's data, and this is all the data that is displayed by the Jupyter Notebook by default. So in the fifth question, display the first 5 and the last 5. To display the first 5, I've used the head method, which displays the first 5 by default. And if I give the argument of 10 here, then it's going to display me the 10 items. So this right here, and the default value of head is 5, as you can see. And totally opposite to head function, we have tail function, which displays the last 5 values of any data set. So we have this tail function. Choose any 3 columns, access them with the bracket notation, and display the first 5 rows. Already. So I've chosen date column, total volume column, and the total bags column using the bracket notation. So this right here is the bracket notation, in which we write the name of the column in the square brackets within the single or double quotes. And using again the head method, I've displayed the first 5 values of that. So there we go. This is number 10. Already. Select one column and access it with the dot notation. So data.date is one example of it, which I have accessed using the dot notation. As you may see the difference between the bracket notation and the dot notation. All done. Multiply the total volume and the average price column and store the result in a new column called estimated revenue, and then display the first 5 rows of this data to confirm that the column was added and has the correct value. So using the bracket notation, if we put any new column name, so it will automatically add that column to the data set, and the estimated revenue column is equal to the data total volume multiplied by the data average price. Since both total volume and average price are of int, as you can see, using this particular total volume is float and the average price is float as well, so our estimated revenue would be in float as well. So there we go. And I have again using the head method, I have displayed the first 5 values of this particular column. if 10 executed already. Now I need to create a data frame that is grouped by region and type, that includes the average price of the grouped columns, and then reset the index and display the first 5 rows. So what I did, I created a new variable called new data, which is going to store my this new data frame, and using my old data frame which is stored in the data variable, using the group by function, which took two columns, that is region and type, and taken average price as the mean and stored that in the group by column. As you can see, it has region, Albany, type conventional, and the average price of this. At Albany organic, so you can see it is grouped by the region and the type. So with one region there are two types, conventional and organic, and it has for the value of those are the mean of the average price of those particular type of avocados. And I have reset the index name is equal to average price. Alright, what if I don't do so? What if I don't reset it and try to run it? You will see it is showing me the data, but it's bit of a weird representation. That is because what the reset index does is it reset the index to 0 1 2 3 4. You see this particular sequence of 0 to 4. This is because of the reset index. Otherwise the default index will become the region, then the region would become the default index Albany, then the Albany, there would be two type, conventional and organic. So if to access any row, I need to search using the Albany. But if I reset this particular index, then I can access it by using 0 1 2 3 4 and so on. Alrighty. So the 10th question is to create a bar plot that shows the mean, median, and the standard deviation of the total volume column by year. So what I did was I grouped the data frame, which is stored in data, and I grouped by the year, and I aggregated, and I selected the total volume, used the aggregator function to find the mean, median, and the standard deviation, and I plot. Then to plot, I used the bar function to plot it in a bar format. What if I remove the bar? Let's try this thing. Nothing. Yep, you can see it's in a line, not in a bar format. But with the bar method, you can plot this particular graph in a form of a bar, which is grouped by year. You can see from 2015, 2016, 2017, 2018, and you can see the mean is although stationary, the median slightly increasing, but there is a significant rise in the standard deviation of the avocados total volume. How many unique regions are there? So for that, what I did was using the bracket notation, I selected the region of the data frame which is stored in data, bit of vocabulary going on, and using the n unique functions, I calculated the unique regions, which comes to be 54. 54 unique regions in this particular data frame of avocado. What is the average price of each type of avocado, organic and conventional? Be sure that just the type, average price column in the result already. So for that, what I did was I grouped by the type. You can see type and average price, and I find the mean of the average price of these particular types, and again I reset my index to type. What if I don't reset the index? Then my type would become the only possible way to access the particular row of the data frame. So back, hold on. Which region has the lowest average price of organic avocados? Hint: create a wide data from the group data that you created in section B9. So what I did was I just used the section B9 data frame, which is stored in new data, and instead of going through all these steps, I just use the new data and pivot the table. What pivot table does is it will convert the columns to rows. This is very layman explanation for the pivot table. And then I selected the index as region, columns to be the type, and values to be the average price, and sorted that values by organic. And using the head method, I displayed the first 5 entities of that. So this right here is my data. As you can see, it's pretty long. And using the head method, these are the first 5 values of this particular new data. Have the total bags sold per year of each type of avocado become more or less consistent over time? Question mark. So what I did was I used this standard deviation function. Firstly, I grouped by the data frame using a group by function and selected type and the year to group by, and I accessed the total bags and used the standard deviation function on that. So with that, this is the particular result that I got. If I read on this, so I have the type, conventional and organic, year 2015 to 2018 for the conventional, and again 2015 to 2018 for the organic. So the question is asking me, have the total bags sold per year of each type of avocado became more or less consistent over time? So if the standard deviation is increasing, then these avocado bags are getting more consistent over time. But you can see they are not getting consistent at all. In 2015 it was 7.5 something, but by the end of 2018 it was 2.03. Again, same goes for organic. There was a slight increase from 2000. There was a major increase, sorry, from 2015 to 2016. It went from 2.5 to 6.7, and but by the end of 2018 it is just 1.4, which is a dramatic drop as compared to 2016. So this right here is the end of the video explanation for this particular task P2, and thank you for watching the video.